Hello and welcome to another free code session. My name is Jason Bach, and I'm going to start working on a experimental idea. This is actually something that came up in a conversation with a friend of mine who I was also going through some ideas with how to handle static abstract members in interfaces, C#11 for rocks. So that's something I did initially, a couple things when I was streaming. And as I've said, I've kind of put streaming on hold for a while. And I'll eventually come back to doing these C#11 features in rocks. The static stuff kind of tripped me up, and I still don't have what I would consider to be it may be a decent design, but I'm just not entirely confident in it. And so I'm still kind of just mulling it in the back of my head. But when I told him about this feature and he started being the person that he is, his name is Keith, he started diving into this more and more. And then he said, wouldn't it be interesting if you could do something like this, but you can't? And then he said, well, maybe there's a way to do it with reflection. And of course, when I heard reflection, I started thinking source generators. But you know, as you're going to see in a moment, you actually need the reflection to make this work. Typically, when I hear of people doing a lot of reflection-based work, that's not a 100% guarantee that you should remove that and do that as a source generator. But to me, that's also a target. That's also particularly a place where you could say, I might be able to get some performance gains if I take out the reflection-based code. In this case, again, though, we can't do that. It's actually something that's going to be needed, but in any event. So kind of rambling here a little bit, but the point is he had this idea and I've kind of run with it. And so what I'm going to be doing in this episode is just kind of laying the groundwork, talking about what the problem is and how I plan on solving it, and then showing just a simple, like a concept of it in action. It's actually not source generated, but that's kind of the fun things about source generators is that you can say, well, if I can write this C# code, then it's just a matter of generating it. And I'm 99.9% confident I'm going to be able to do this. So, but we'll see. It's sometimes the fun thing too. It's like, oh yeah, I can't actually do this, but this also will take some parts of things I've done with the partially applied library that I wrote. So, and I think it's important to have, a lot of thought and design and ideas put into place first before you start doing anything. And there's a tension here. There's a balance. You can't get into what's called analysis paralysis, where you're doing nothing but trying to think of every possible thing that could go wrong or what you need to consider, because you'll never actually do anything and you'll never be able to, produce something or publish something or have something in place. It'll just be all a bunch of documentation and notes, and you don't actually ever do something. So, especially in software, that's something that's important. But I also think that if you just go in and start typing out a bunch of code without any thought, without any time taken to sit there and go, is this the right approach? Am I doing the right thing? If you don't do that, then you can quickly get into an area where you're like, oh, I'm really messing up, or this is definitely not the right approach. And of course, that's where I think there's a balance between the two. I think there's worth in thinking about what it is that you want to do and spending that time. And sometimes you really need to think this through. But there's also that point where you have to say, I got to just start writing something, because that has benefit too. You're going to start to go, oh, I forgot about that case. But I think if you have a good design in place, or at least you've put that effort into that design, that will help reduce some of these corner cases. And hopefully, if you do run into those, you can kind of say, well, how do I work myself out of this or get around it or something to that effect? So that's why I want to spend this episode mostly just going through the scenario and what my design is, because I want to emphasize that point of it's worth doing this, in my opinion. I've said many times, you have to have tests. You have to have tests in place. That's the only way you're ever going to be able to change code with confidence. In fact, my day job, there is something that one of my coworkers had to, just this past week, he had to go in and change something because, that there was potentially a bug or a case that this code wasn't handling correctly. And from my understanding, there was already a decent set of tests there in place. So that helps, because then you can say, I can change this, I can add this, I can do something to it, and then have a level of confidence that when you rerun the tests, you didn't break anything that currently is in place. Now, of course, I also told them you probably want to write a test first when you have a potential bug to show that you can make the bug happen. And then when you make your change, it should now light up and be green. That's another thing that I always tell people to do. And he's a guy that he's relative. He's been in as a professional developer person at the company. He's been there for 10 years, and he's smart. He's got a lot of good ideas, and his approach is good. But he's relatively new to software development, and that's where he's actually trying to get his career to go, is in that area. And so that was one thing I encouraged him on, is make sure that you're writing a test first when you're trying to fix a bug, because you want to make sure that you can make it red first and then you can make it green. I'm typically not a huge fan of test-driven development in the sense of it being test-first development. I don't particularly do that. That whole write your test first and then make them all fail, then you write code to make them pass. I personally, as long as you have a good set of tests in place before you say I am done with this feature and you've committed it, that I think is sufficient. Once you've gone beyond that point, that's when the clock is ticking. That's when you have legacy code. That's when you are going to start to make it's going to be harder and harder over the time to make sure that you've done those things. So in any event, what is this thing that I'm going to be working on? What am I going to be showing you in these next couple of episodes, or how many it takes to do? So here's a scenario. Let's say that I have a method that you see here, where the method is taking an arbitrary value, meaning it's of a type that can be inherited from. In this case, object is the simple case to show. So maybe there's stuff that's done before it or whatever, but what you want to say is, if it's of a particular type, then I want to do something with it. And while this I don't particularly care for, and saying I'm passing in an object, you want it to be of a particular type. This is not uncommon at all. In fact, one case that comes to mind for me is when you are doing stuff with Roslyn, where you are doing, like in source generators, you're saying you have the ability to start doing these incremental filter passes types of things. And you're given a syntax node, but you're not just, in most cases, you're not just looking for a syntax node, you're looking for a particular kind of syntax node. And yes, you can say is kind, raw kind, all those things, but you also probably want to do more than just saying, is it of this particular node kind? You want to actually look at things on that specific type. So you'll say if node is invocation expression syntax, and then you say invocation, and then you do something within it. Very typical for what I've done. So not uncommon to do these kind of casts at all. And so you say, if it is of this type, then I do something specific on that type, in this case, split. C#11 is going to start to add in this thing called static abstract members and interfaces. And one of the things that, getting back to my friend, said, what if you could do something like this, where you're saying, Well, I'm passing into a method just some arbitrary T type. And what I'd like to do, and I have to comment this out because it doesn't actually work, is I want to say if T is of a specific type, okay? And actually in this case, what would probably make more sense is because we have this interface here is to say, is it of an iWork type? Okay. Where iWork, not implements, it defines a abstract static method called work. Okay. So if T is of iWork, then do this. And you're going to say, well, I could make T be constrained to that, but it's similar to this where you're not constraining the parameter to be of a specific type. You're saying it's just a generic, T type. And only in a certain case, I want to say if it is of a specific type, then do this. Now you could say I could have a local method here and I could define a method that is constrained to make sure that the generic is actually of an iWork type. But you still then have, you can't do this check here. That's not even allowed. That's not even valid code. Okay. T is not a type. So this doesn't work because this only works for instances like it does here. So the point is the language itself doesn't support this concept at the moment. There was a conversation I had on the Discord channel for C# where I asked about this, and somebody I think from the C# team said, this is something that we know has been requested, or we've even thought about this already for static abstract members. It's not going to be in for C# 11, but it may come in a future version of the language where you can do something similar to this, where I could say if T is iWork, and then I'd have maybe T work here to say that's a type, and then I say T. And what this would actually do then is say, for a type that implements iWork, that's the work implementation that I want to call. Okay. So what he did is you can actually do this if you're willing to invest some time in reflection and find the method and do that work. And so I started running with this. I started going, okay, well, can we generalize this? Can we make this so that it's simple? So somebody could do this in like one line of code and say, I want to call this member in this way. And so what I've come up with is this idea of what I call a static cast. Now, this is not a static cast in terms of C++. I am not a C++ developer. I don't know really anything about C++ other than I could probably read some very simplistic code and go, okay, that's what it's doing. I know there is a static cast operator, I think is what it is. And I have no idea if it's even remotely related to this. I'm calling this a static cast because what you're doing up here is a cast, and it's a instance cast in a way. You're only doing this for instances. This is going to be done on statics. This is going to be done for static types. So that's why I'm doing this. And it's only for the case of static abstract members. Okay. So how is this actually going to work? Well, I have this big document here that I've been creating, and we've already talked about all this. How would you actually make this work? That you might have multiple implementations of iWork, blah, blah, blah. And how can we do this with source generators? So here's the idea, is you're essentially going to do something like this. Yeah. Actually, let me make this a little bit bigger so it's easier to read. So all you're going to say is static cast. You're going to pass in two generics, and then you're going to say dot, and then whatever member you want to invoke on it. Okay, and then the details are going to be coming. Just hold on. That's what you'd actually type in code. So for this work iWork idea, it would actually end up being something where in this case in my documentation, I'm saying it takes a string. Okay. So what I want to say is I want to just arbitrarily call work on work, given that it is an iWork interface. Now, in this case, you might say, well, this is a little wonky because I know that work has that implementation. But what I'm saying is I'm passing in a T. I don't know what T is. It's coming from some method that I'm a part of. And so in that case, I don't know if it does or not. And so I'm saying if it implements iWork, then call work on it. Okay. So actually that I'm here, I'm going to put this in here. like assume T is a generic parameter to a containing, the generic parameter from a containing method or type, something like that. Okay. So that's what we're trying to do. Okay. Again, if you knew that the type that you want to call is work, you would just do work and you wouldn't even bother doing this. This isn't the case where I don't know what the type is for the first parameter. Okay. So what I'm going to do from a source generator standpoint is I'm going to look for method invocations, simple member. It's really member access expression, where the first part is it has the name StaticCast and it has exactly 2 generic parameters. This is something, again, I mentioned I've done with partially applied, where when you're saying I'm doing a method invocation that doesn't exist yet. So you start typing it all out. And once you actually type it, the generator will finally find this and it will go off and do it. And it just automatically works. So it's kind of it's a little bit of a stretch in what you're doing, because you're initially writing code for something that doesn't exist. Only when you say this is what I'm intending to do, does the generator pick it up and go, I'm going to generate code for you to make this actually work and be satisfied. Okay. So it needs exactly 2 parameters, 2 generic parameters to the type. The name of the call is what we use later. So I'll get to this in a moment. So you don't really care about this part afterwards right now, in terms of you just care about this. I don't care if there were actually like TA or something like that. I don't care if there was a type involved in it as well. All I care about is that name. If the second type is an interface and it has static abstract members that match the provided name, then we can generate all the calls. So this would actually be, I think I have this already. No, I don't. I need to put this in my diagnostic list. If the given member name isn't found on TAS. So yeah, I think, yep. Okay. I want to keep a list of the diagnostics as well that I need to create in certain cases. So where was I? Yes. So I basically look for that, and then I look for all the calls that match that, because you might have overloads. You might have a work that takes no parameters. You might have a work that then also takes 1 parameter. So I want to just find all of them, and then I will generate a thing called work with those correct parameters and return types. Okay. Now there's also a case here where we might have duplicate matches. There may be a case as you're writing code where you have an interface that's called, like iStuff, but it has a static abstract void work with no parameters. And you might want to do that for StaticCast. How do you differentiate between the two? That'll be solved in just a moment. We just have to make sure we don't do duplicates. Okay. So if the second generic parameter is open, so that may mean that this thing you're passing in as T something. Okay. So that's, again, coming from that you're in a method that has T something defined. If I can't determine that it's constrained to an interface type, okay, or what you pass in here is actually a class, that will be a diagnostic. Okay. I don't have to throw a not supported exception, because I wouldn't even generate code to support this if that's what you tried to, if you passed in just work there, no code would be generated for this. Well, now that I'm thinking about it, it could possibly be the case where this wouldn't work. If you pass in something that is a class here, not an interface, then that would fail. Even though somewhere later on you might have that second interface that you pass in that makes it work, no pun intended, this will still have a diagnostic that wouldn't let you do that. Okay. So there's probably, again, corner cases that as you go through things, you start running into. So I need the first parameter. I don't care. I really do not care what you're passing into that. it won't affect the generation. This one doesn't affect the generation other than it needs to be of this type so I can find all the members of that name. Okay. So we only generate members that are public, static, and abstract. So the first thing I'm going to do is generate a class that has this shape. I might make this partial. I'm not sure at this point. But you know, for right now, I'm just going to have this be static class. Okay. I also need to get all the namespaces because I need to put all the usings there. I need a nullable enable. I'm not going to put this in a namespace though. And that's going to be on purpose because I don't want you to have to feel like you need to include a namespace somewhere. This is essentially, I'm trying to mimic a operator in C#, which as a side note in C# 11, there's apparently going to be a warning wave that says you shouldn't be naming members with all lowercase. This is to reduce the possibility of somebody using a potential keyword that wants to be used in the future. This is something that's been problematic with var and async and await, maybe init. And now I think in C# 11, they're probably going to have required properties, which means you need the required keyword. And they want to make it easier for themselves to add in a new keyword without fearing that they're going to break somebody. Like with var, there was the possibility when they added that somebody created a type called public class var. And that's valid legal C# syntax, you know, for C# 1 and 2. They had to keep that there for backwards compatibility. I don't know if they actually ran into any cases with that. I'm not sure. Async and await was a similar example. So they're trying to get away from that. And so what I actually thought of doing as a joke is doing StaticCast. You know, that's actually not easily worded, and I could do this, and then I'm going to get all the confusion from all the C++ folks that are like, what are you trying to do? That's not exactly the same thing. It's like, no, that's not what I'm trying to do. So I'll keep it like this. But as a side note, don't name things with all lowercase because they're going to start making it so that that's just not, you know, at least you're going to get a warning maybe in the future that it's actually not allowed at all. But this is just for member names, not like variables or anything like that. Things that people can see. For example, you can't see my variable declaration or my field declaration outside of the class. Obviously, if you use reflection, you can look at some of these things up, blah, blah, blah. That's not the point. The point is you can't see these things. A type name or a method name, these can be, and that's what they're trying to get away from. So in any event, that's what it's going to be called. Okay. There is no constraint like where T has got to be equal to T as, because the point is I may not know if it does or not. Again, it's that if the object parameter is a string, the same thing, if T is of this type, that check has to be done at runtime, not at compile time. So I'm not going to put that constraint in there. Okay. So then I look for all the members with that given name. I don't care about parameters, generics, anything. I just look for all the instances. And so what I'm going to do then is generate a instance of that static method. StaticCast doesn't implement these interfaces. It just says, I'm going to have a method that looks exactly like what you just are targeting. And I'm hoping I can actually make this so that this is really simple to do. Like I can actually look at the method invocation or the definition on the interface type and say from the node, just what's toString on it? And it'll actually just do this for me or very close. We'll see. But I have to create this. Okay. And then the first thing I'm going to do is call this method verify. We'll get to that in a moment. I'm going to make sure that T is assignable to this. In other words, does T implement the interface? Again, you got to keep in mind, I've already verified that I'm only going to generate this if all these interface abstract static things have been satisfied. So then I'm going to find the method, and I'm just going to assume this is work because again, I wouldn't have done this in the first place otherwise. So the name's going to be fine and everything. I'm actually, yes, I putting it in as a string here is fine. I was thinking of making it a name of, but if you changed the name of the interface, that would force this to change, which would then regenerate and force that to change. So it could be name of, it could be this. I don't think it's really going to matter. But then I get the interface name, the interface method. I'm going to get the target method. You'll see what that does in a moment. And then I invoke it. Yeah. So in fact, I think this can be, it doesn't have to be this, because we're going to make sure that you are always giving a method back. Okay. So yes, it's reflection, but that's what's necessary for this to work. So first of all, what's this verify? The verify, I'm not sure if I need to check this, because the generator itself wouldn't allow it to be something other than an interface type in the first place. So even if you tried to call it, it wouldn't work. The only way that I'm putting this in here is if you try to actually call a StaticCast method or member through reflection itself, and then I would have to check this. So this is mostly for completionist's sake, but really this is never going to happen. If it does, it's really, really something went completely bonkers wrong. But anyway, so I have that helper method that's going to be in the static class itself. Now, if it's a partial class, this is something that'll be a little weird, because I can only generate it once. That's why I'm thinking I don't want to make it a partial, because I just want to do this once for everything. But again, we'll see. So the other one, get target method. There's this thing called interface map. And the reason I'm doing this is because you may be implementing the member explicitly. And then it got really hairy for a moment, because I'm like, how am I going to know which one to call? But interface map takes care of it. That's why up here, we're getting off of the interface type, the method, not on T. Okay. So we're going to get that interface method, and then, we're going to get the interface method. Then from the target type, we're going to get the map based on that you actually implement this interface. We've already checked that. We know that's true. And then we're just going to go through all the interface methods. Once we find the exact one, we're going to say what maps to it from the target method standpoint. And that's the one we're going to return. Okay. So yeah, this up here doesn't need to be like that. We can just, because we know it's going to be passed. As I have in my comments here, it'd be very weird to see this not have a map. I can't think of a case why you would run into this. So we'll throw an exception, and hopefully we never ever see this. Okay. So properties are also going to be called in the same way. So if you had a property, if you had a static abstract member of a property in an interface that was called name, returns a string, is read only, then you could call it like this and get the value of name. And so we're going to do exactly the same thing, except we're going to get the get method and we're going to get the property. Okay. Once we have this, same thing as before, and we just invoke it the right way. Okay. So notice that when we're returning something, I'm saying default. This is something I might need to do something with like a maybe type to say either you got something back or you got nothing back. I'm playing with that idea right now. I'm not sure if that's actually something that I'm going to need to do, but I think it's going to be necessary, because I need to differentiate between when you actually did call something or when nothing happened. Because again, the case of what you have right now is that it's an if check, and you would know that you're doing something or not doing something. In this case, I have no idea. So I need to be probably a little bit clearer on that. So that might be why I have like some kind of maybe type. That's something I'm debating in my head. Operators, you can define operators in interfaces now to be implemented. An initial look at this, I don't think StaticCast is going to work very well with operators. It's a long story. I might come back and revisit this in the future, but for now, I don't think I'm going to allow you to do that, just because the way the types work with the generics and the operators and everything else, it's a little weird. So I think I might just not do that right now. One other thing, the thing I said about what happens if you have two interfaces that have a member of the same exact signature. So I'm going to put this in my notes once I'm done with this episode. One of the things I have to do is say, if I generated, for example, let's come back up here. I generated this, and then I run into it again, I won't do anything. So I need to keep a hash set of signatures around. Okay. And I need to put that in my notes so I don't forget. The nice thing about the way this works here is that it is generic, no pun intended. I don't care if you gave me an I work or an I do stuff or whatever it is. This is, I've already determined that calling work for that type, which that type is on StaticCast, I should have a method like this. What the type of it is, I don't care, So I just need to make sure I don't inadvertently generate this method definition more than once. Okay. So that's something I just need to keep in mind down here. And I'm going to write that note so I don't forget when I do that for the generation. So that's called StaticCast. I'm going to put the link to the repo in the description, because by the time this video is released, that should already be there. It's private right now, but by that point, I hope to actually have, in the next episode, I'll have the initial project and everything made, and then we're going to start actually hopefully start creating this and get some initial success. We'll see. It might take a couple episodes to get there, but that's where I'm going to be going in the future with my recordings. So that's all for right now. Leave any comments or questions below. See you in the next episode.